Hello. How you all doing this fine Monday afternoon? What's up? Hey, good afternoon, Mayuk. Hey, Santosh. How you all doing? I'm gonna get started right off the bat with the homework questions. Thanks for answering them. Yeah, there are a couple of you who did. Naruto, Shalini, and Mayuk. Good job on that. Yeah. Before I do that, everybody can hear me and see me clearly. Yeah, no issues, all of that. Hey, hello, Arunji. Doctor Sahab, hello. Aspiring doctor, already doctor. Badhiya, yaar. It's very nice. Hey, Ranjit, can you move me to the other side? I think it's covering the thing a little bit. Just move me to the other corner, huh? Hey. So you're able to hear me and see me clearly, right? All good? Hey, Decaf, what's up? So I got answers from three people, right? Naruto, Shalini, and Mayuk. Shalini and Mayuk. पहला सवाल था homework question का. I'm just quickly doing that. Adsorption theory of catalysis. Speed of reaction increases because concentration of reactant molecules at the active centers of the catalyst becomes high due to adsorption. Nahin, this doesn't sound right. Process of adsorption, the activation energy of molecules becomes large. Nahin, ये भी doesn't sound right. Adsorption produces heat. This is okay. And this, but I don't think speed would matter. Adsorption produces heat, but इससे speed नहीं बढ़ती है. Okay. Adsorption lowers activation energy. Yes. Catalysis. We're talking about the theory of catalysis. This seems to be the right answer, which I think everybody over there got it right, which is great. Yeah. Hey Sonali, what's up? That's an upside down D, is it? The other one, this was an interesting one. I thought that there would be some sort of divergence on this question, but everybody answered this correctly as well. Alcohols are dehydrated to hydrocarbons in the presence of acidic zeolites, and zeolites are porous catalysts. Everybody here, at least on the options, right? I mean, it was Naruto and Shalini and Mayuk. These three superstars, they gave me the answer to be B. But can you explain to us why is it that it is B? Assertion and reason दोनों सही हैं, but कारण, the reason, is not the right explanation of assertion. मतलब zeolites are porous, we know this, and alcohols are dehydrated. Why is this? If you remember how I ended the last session, hey, ये 12th class का chapter, Vikram ji. Just look at the thumbnail, that should give you that idea, bro. You remember from the last class, I told you that all organic reactions are acid-base reactions, right? And that was a hint to this question right here and there, that this happens because of this acidic nature and not because they are porous catalysts. Yeah, sure, porous catalysts speed up the reaction, but the fact that they're acidic, that is what causes the reaction to go on. Remember that this OH bond in the presence of H plus very happily cleaves. Okay, this becomes OH2, etc. This cleaves, these guys go here. You know the whole thing, right? From organic chemistry, etc. Anyway, good job everybody. Good job. Hey Suprabha. Okay, let's start with the fourth session on surface chemistry. I hope you've been reading the NCERT because as I told you last time, this is going to get a little dense. NCERT की एक line important है surface chemistry की, so much so that even in the advanced exam, things are asked directly from NCERT. Okay, so please do that. Yes, Mayuk, absolutely. Lewis acid is the right term. Yeah, what kind of acids? Yeah, thank you for that. Yeah, these are the things we're going to cover today. It looks like a lot, but this is more or less, a short part of the session, maybe around 20-15 minutes, and the rest of it is going to be this. This is pretty interesting, and I think the first part of it, which is this much, आप लोग already कर चुके हैं in is matter around us pure. Do you remember this from 9th grade? इसमें आप लोग काफी हद तक ये चीजें कर चुके हैं, which is this one of those. Hey, I'm great, Sheikh. How are you doing? Aslanji, how are you doing? So maybe you remember this, maybe you don't. It's okay. But अगर ये part आपको tricky लगता है, go back to 9th grade textbook. आप लोग online देख सकते हैं NCERT. You can read it up. ठीक है, let's get started with enzyme catalysis. Maybe something that's very useful to you as aspiring doctors, right? Enzyme action. If you're going to do lab work, so even if you're going to do research in biology, this is going to be very fascinating and useful to you. Class 9 so many memories. I hope they're positive ones. I have some nice videos on this on the app from 9th grade. You should check those out if you want to look at that. Anyway, let's focus on NEET right now. Enzyme action. Okay. It says that enzymes are complex nitrogenous organic compounds. Maybe when we do biochemistry, then we'll look at this in detail. Yeah. Maybe you have that. I think that biomolecules. I said biochemistry, but I meant biomolecules. That chapter is there in chemistry as well as biology, right? So इसमें इन चीज के बारे में is touched upon in biology, not so much in chemistry. Anyway, produced by living plants and animals. Okay, so what exactly do enzymes do, right? They catalyze the reaction. But these are biological reactions, which means that they're very sensitive to changes in the environment. What do I mean by that? We'll look at that. Hey, Suprabha, you have the Akash Premium. That's awesome. That's great. ये बिल्कुल वैसा ही slide है because वही slide है, and I've made some changes to those to teach you guys here because you've got the best content, right? No doubt whatsoever. Akash Byju's has the best content, hands down, made by an army of amazing people. Okay, great content and media folks. So here's the deal, right? These guys are protein molecules and they have a high molecular mass, and it's written here that they form colloids. Colloidal solutions in water. Remember I said कि colloids के बारे में 9th grade में पढ़ाया था. Don't worry, we'll wrap this up with this idea of how does it form colloids as such. Yeah, basically बहुत बड़े particles, whether proteins and all of that, can form associated colloids. We'll look at that. Sorry, not associated, macromolecule, मतलब बड़े molecule वाले. There are 3 types of colloids. We'll look at that towards the end of the session. Many reactions can happen, and these basically, the reason why your body functions is because of enzyme catalysis. Without it, it would not work. But sometimes these enzymes जब ज़्यादा secrete हो जाते हैं, that's also a problem. So you may want to inhibit them. We'll look at those 2 things. Yeah. So basically, what happens here is that how does the whole mechanism happen? Yeah, at a site. That is coming up next. पहले a couple of examples. Inversion of cane sugar. This has been asked. Okay. कौन सा enzyme होता है यहाँ पे? Anyone? Any guesses here? You have Akash Premium. That's great. That's awesome. JEE aspirant. Wow. That's great to see such a diverse set of students over here. I want inputs here, folks. Maybe you already studied this. Just to make it interesting for people who have already studied this. Mayuk ji. Looks like, see, I was right. कुछ हैं हमारे दोस्त यहाँ जो ये chapter already पढ़ चुके हैं और फिर भी they're gracing us with your presence. Thank you so much. It's nice to have all kinds of students here. Mayuk is absolutely, I was going to say Akash again because I read Akash. Mayuk is absolutely right. This enzyme is invertase, and this really speeds up this reaction. Inversion of cane sugar, glucose, fructose. You know that there's a difference of just one OH and H group in between this and this. Which one's which? We'll do in biomolecules in detail. मुझे honestly अभी याद नहीं आ रहा है. Now, another example of this is conversion of milk into curd. ये कौन सा enzyme होता है? आपको मालूम है क्या? रात को आप दही जमाते हैं, तो दूध में थोड़ा सा दही जो ऑलरेडी बना होता है उसमें डालो and you get the most tasty curd in the morning. What enzyme is it? Lactase. Okay, Mayuk, pretty close. I think I would want to go. Okay, yeah, I give that to you actually. That works. Both lactobacilli and lactase. Actually, this is the bacteria. I know what your argument is going to be. कि ये तो bacteria है, enzyme तो lactase है. इसको सोचना पड़ेगा यार. This is like one of those gray areas where I think I'd accept both the answers, but I'll have to check with my bio friends to know कि exactly कौन सा है. Yeah, I'd want to go Naveen with lactobacillus, but I think lactase also kind of works. Okay, I'll get back to you on this one. Great inputs. Thanks. Now, the thing that I promised you, right? The mechanism of how these enzymes work. And this is something that's been tested so much that even before I, got back into teaching, I would always remember this. Enzyme is because of lock and key mechanism. वो NCERT में अच्छा सा diagram बना हुआ था जहाँ पे एक, अंदर जाता है बाहर आता है. That perfectly fits in like Lego blocks. Exactly that thing. Yeah, lactobacillus. Thank you. Hey Krishna, what's up? So ये चीज बहुत simple है समझने की. Basically, it's very very specific. That's what I was trying to say, right? जिस shape का enzyme है, exactly उसी shape का molecule वहाँ पे आके react करेगा. ये cavities is what I'm calling a shape. Okay, shape obviously not a technical term. Cavity is the right technical term to write if you have an exam or test. And these are the active centers on the surface of the enzyme. Okay, what do you mean? Check this out. Okay, the molecules that come in, they have a complementary shape. यानी कि Lego blocks की तरह exactly एक के ऊपर fit होते हैं. जैसे कि ये key fit होती है into a lock. And एक mechanism होता है इसका, मतलब कि दोनों react किए, then they form a slightly high energy complex, and then things break away and you get your products. This is something I'd shown you in the last session also, right? But we didn't get into detail of mechanism. यहाँ पे भी इतना detail में नहीं लिखा है, बस it just says there's an activated complex, just like you have in SN2 reactions, right? कि there is an activated complex, high energy complex, and then it breaks down. Not a complex, sorry. That's a transition state. Let's call it a transition state. ठीक है. Hey, evening, Hari. So this is what I was talking about. Hold on. I think I can get this to play. Yeah. Oh, already चल रहा है. माफ कीजिएगा. Let's go all the way from the starting. Yeah. So see, this is your enzyme. The blue stuff is your enzyme. The green stuff is a substrate, and that comes and fits right onto this, just like a key fits perfectly into a lock. I'm hoping this is going to move sometime soon. Yeah, there you go. It starts moving right now. And that's it. This is a similar diagram to what you have in NCERT. You don't have to draw this fancy thing. You can draw what's in NCERT in a theory exam. And this is how it works. A lock and key mechanism. And then hold on. We're just going to pause here and write this out, right? ठीक है, वो substrate आया and then products आपके जो बने, maybe this product was simply just breaking apart of one molecule. Maybe. This is an example of that. And then they separate out and they go away. Hold on. Let me go back to that and play that for the rest of it for you. Yeah. That's it. That's it. Okay, great. So, the idea है कि दो step हो रहे हैं broadly. Yeah. एक step पहले, that substrate comes in, gets attached to the enzyme. That is what I'm calling, E plus S, giving this ES and this star kind of a symbol on top, right? This right here is the activated complex. This is what I was calling the transition state. ठीक है? एक बार ये बन गया, तो you know how it is, right? When a bond is broken, then a lot of energy is required. But to form bonds, well, energy is released. So this is an exothermic process. Is that all right? Bond formation gives off energy. Yeah? Bond breaking requires energy. You remember that clapping wala example that I gave you last time, or maybe a couple of times, classes back? This is bond formation. आवाज आई, मतलब कि energy release हुई. And to break bonds, you require energy. So this process is great. जल्दी हो जाता है. ठीक है? And this is the key thing. This is why you'll see later on कि बहुत, this is why the number of times by which the reaction rate is enhanced is millions of times literally. उसके बाद ये वाला process may be a little slower, but it's okay. ये decomposition होता है, मुझे product बन रहा है. And this is very, very specific. यानी कि जैसा shape होगा, exactly वहीं पे होगा. Right? Nothing else can get formed over there. Hi, Abhinandan. Hello. Hi. Okay. So, as I was telling you, the rate, right? Literally a million molecules of reactant can be formed, can be processed by the enzyme per minute. It seems like a lot, but think about it, right? 1 mole of stuff has 10 power 23, things, number, that's a number, right? So million doesn't seem like a lot in compared to this. But remember, these are big things. When you talk about a mole of electrons, they're pretty small. When you talk about a mole of H atoms, they're pretty small. Helium is pretty small. These are huge, huge, huge macromolecules. You know this better than I do, right? So, isliye a million is very, very impressive here. Hey, NEET 25, Jesham to you too, I guess. Yeah, don't spam here. Yeah, we are here to study. Let's talk about surface chemistry. I'm glad to help you out. And yeah, love that sentiment. Bhagwan ka naam lena bahut achhi baat hai. That's great. But let's focus on surface chemistry. Okay. So, I told you it's highly specific, right? Yani ki, what happens here is that only a particular enzyme like invertase is going to help with that inversion of sugar. Lactobacillus cannot do that. Yeah, similarly, invertase cannot help convert dahi, दूध to dahi, right? So they're very, very specific. Obviously, this is, at the biological level. So, yeah, this makes sense. Any doubts so far, guys? I'm not going very fast here because maybe this content is new to some folks and some people are going to be watching this live. Not live, just for them. Do you want to, yeah, any doubts? Mayuk? Okay, great. Hey man, don't spam, man. NEET 2025. Come on, be a sport. Yeah, you're spoiling the experience for the rest of these folks here. Yeah, come on, be a sport. Yeah, this is a studying session. Let's focus on this. All right. So, the most important thing, like any biological reaction, and it's a request. It's a humble request. Yeah. The most important thing is that all of these reactions, they happen at a particular temperature. Optimum temperature. Now, what's the optimum temperature? Your human body, you know that अगर 1 degree भी ऊपर चला गया Celsius, then you're like, अरे यार fever हो गया, बहुत बड़ी बात है, right? You know this better than I do, right? Even a single degree of centigrade or maybe a couple of degrees of Fahrenheit makes a big difference to everything that is happening inside your body, right? This is why these enzymes also operate under this perfect optimum temperature. And same way, if it gets too cold, you go into hypothermia, your body functions stop. So this is the ideal temperature. This is a very big temperature area, 12 degrees Celsius. 12 Kelvin is the same as 12 degrees Celsius. They're both the same, right? And this is the optimal temperature for these reactions to happen. All right, great. Hey, that's great. Thank you, NEET 2025. Focus on this. Yeah, narrow range of, Mayuk. उसने मेरी अगली बात मेरे मुंह से छीन ली. That's what I would say in a positive way. I like it when students know exactly what I'm going to say next. That's like the best kind of students. That means they're active. वो लोग पढ़ के आए हैं, and that's what I want you to do, right? In college, especially if you're going to be doing medicine, right? The only way to keep up with your courses, with all those moti kitabe, is to read them in your free time, like storybooks, make notes. There's a guy called Ali Abdal. I really respect him. Yeah? I've been following him for many years. He's a doctor from the United Kingdom, and he makes these beautiful notes. He has an idea of how to stay productive and all of that. He's dabbled into many other things, but his idea of how to make notes, how to study are really good. You should check that out. Anyway, so yeah, great that you've been reading NCERT before you've coming here. Keep that up. They also are active until a particular pH. And this pH range also is very interesting. Anyone wants to say कि क्यों 5 से 7 के बीच में pH होता है? Hey Anonymous. Hi. Thank you for joining in. Hi. Yes, absolutely need 25. Revision के बारे में बात करेंगे. Right now I'm focusing on teaching this. Optimum pH मतलब कि एक particular pH range के अंदर ही चीज़ें active होती हैं. अगर आपको ये चीज़ अभी आइडिया नहीं है, बट लेटर ऑन यू विल फिगर आउट कि मोस्ट अमीनो एसिड क्या होता है, एक NH ग्रुप होता है और एक C डबल बॉन्ड O ग्रुप होता है. दोनों चीजें एक सेम ही जगह पे हैं. द नाइट्रोजन हैज एक्स्ट्रा इलेक्ट्रॉन्स, कार्बन इज डेफिसिट ऑफ इलेक्ट्रॉन्स. सो लुइस एसिड लुइस बेस दोनों जगह है. ठीक है, मैं एक ब्रीफ में ये चीज बता रहा हूं. मतलब इट कैन फॉर्म अ ज्विटर आयन. एक पीएच पे ये पॉजिटिव होगा, एक पीएच पे नेगेटिव होगा. पूरा बॉडी की केमिस्ट्री इसी चीज पे आती है. अमीनो एसिड्स क्यों मैंने बात की, क्योंकि अमीनो एसिड से बनते हैं सेकेंडरी अमीनो एसिड्स, टर्शरी एंड देन प्रोटीन्स, क्वाटरनरी वंस, राइट. अगर ये थोड़ा सर के ऊपर जा रहा है, बाद में आराम से पढ़ लीजिएगा. द रीजन आई एम गोइंग इनटू दिस डिटेल इज बिकॉज समबडी आस्क्ड मी व्हाई ऑप्टिमल पीएच रेंज. पीएच मतलब कि H प्लस और OH माइनस आयन की कॉन्सेंट्रेशन, प्लस और माइनस कॉन्सेंट्रेशन यानी कि ये ज्विटर आयन फॉर्मेशन एट द अमीनो एसिड लेवल, हेंस प्रोटीन्स, हेंस एंजाइम्स. Does that clear give you an idea? I know it won't be able to clear your doubt because मैंने बहुत शॉर्ट में एक लाइन बोली और 4 लाइन और बोली, बट थोड़ा सा आपको आइडिया इससे मिल रहा है. Yeah, exactly. Mayuk, I like it, man. I like that, our frequency is matching. You're able to figure this out. It's okay if this is going over the head of some people because we haven't covered this in detail, right? When we do biomolecules, हम लोग उसको detail में जाएंगे. In fact, even when we do surfactants later on, it'll make a lot more sense. Yeah, usually zeta ions they exist in neutral form. थोड़ा pH बढ़ाऊंगा, घटाऊंगा, it could go either way. Okay, Manisha, did I give you make it interesting for you to read up? I know I can't possibly explain your doubt in क्यों ऑप्टिमम पीएच होता है. ऑप्टिमम पीएच क्या है, मतलब इस रेंज में होता है. क्यों है वो मैंने ये बताया. ऑल्सो ब्लड का पीएच इज वेरी क्लोज टू 7. ब्लड का पीएच क्या होता है, किसी को मालूम है क्या? ब्लड इज अ कोलॉइड. दैट्स एन एग्जांपल ऑफ अ वेरी ब्यूटीफुल कोलॉइड. उसका पीएच किसी को मालूम है क्या होता है? कुछ 6.5 इसके आसपास होता है, राइट. तो मेन चीज ये है कि सारे रिएक्शंस आपके बॉडी में होते हैं, राइट, इन योर ब्लड. जो ऑक्सीजन जाता है ब्लड से जाता है, सारे everything happens in your blood and all of that. So which is why 6.8. Thank you everybody. Thank you Mayuk, Deepanvita ji, Sheikh Arsalan ji, thank you so much. So इसीलिए इस रेंज में this is the optimum range. Manisha, I hope I've answered your question. It was a very nice question. I'm not kidding. I'm not messing with you. I'm not ऐसे आपको बढ़ावा नहीं दे रहा हूँ. बहुत ही प्यारा सवाल था, क्योंकि ये बेसिक की वजह से you'll understand everything else that happens. Okay, all right. Otherwise यार these theory things get boring. You have to ask me interesting questions like this. ठीक है. Also, जस्ट लाइक कैटलिस्ट के साथ आपके पास एक्टिवेटर्स थे और पॉइजन्स थे एंड ऑल ऑफ दैट, जैसे भी यहां पे को एंजाइम्स हैं एंड एक्टिवेटर्स हियर, एंड एज यू वुड एक्सपेक्ट देम दे वुड इंक्रीज द एक्टिविटी ऑफ दीज एंजाइम्स, एंड दीज आर नॉन प्रोटीन मॉलिक्यूल्स लाइक विटामिन्स. इसलिए बोलते हैं ना कि विटामिन बहुत थोड़ी सी क्वांटिटी में लेना जरूरी है, कुछ मिलीग्राम, कुछ माइक्रोग्राम. इसलिए लोगों को विटामिन डिफिशियंसी होती है तो बहुत दिक्कतें हो जाती हैं, राइट. दिस व्हाट विटामिन्स आर. Okay, I can only say Sheikh. Okay, great. I wasn't sure, right? So I will just say Sheikh from now. Thank you. Arsalan is the name of a lion, right? In that movie Narnia. Narnia में वो lion का नाम था. Hey, good evening, Mr. Rohit. Team bar to you too. That's why I like the name Arsalan, क्योंकि वो Narnia में lion का नाम था. Narnia is that thing, when she opens the wardrobe and पीछे उसको पूरी दुनिया अलग दिखती है. बहुत प्यारी बुक थी and movie as well. Anyway, so एग्जाम्पल है एक्टिवेटर्स के. सॉरी, लेट मी जस्ट गो बैक हियर, आई गॉट थ्रोन ऑफ माय गेम अ बिट. ओके, व्हाट आर वी टॉकिंग अबाउट? या, विटामिन्स एज एन एग्जांपल ऑफ कोएंजाइम. हमने कोएंजाइम्स बता दिया, अभी बात करते हैं एक्टिवेटर्स की. दे आर टू डिफरेंट कैटेगरी ऑफ थिंग्स, राइट. कोएंजाइम्स आर स्टिल व्हाट काइंड ऑफ मॉलिक्यूल्स? लुक एट दिस. दे आर नॉन प्रोटीन बट दे आर स्टिल ऑर्गेनिक मॉलिक्यूल्स. ये ध्यान वाली चीज है. let's note that down, okay? Whereas activators, they are generally metal ions, metals. That's interesting. Okay, so ये amylase कहाँ यूज होता है आपको याद है? amylase की एक्टिविटी बढ़ती है जब Na+ आयंस होते हैं. Anyone knows amylase कहाँ पे यूज होता है? I think it has something to do with digestion, right? Yeah? Hey, good evening. Hey. Hey, Hari Hiral ji. Yes, yeah, all good here? It increases catalytic activity, but कैसे? क्योंकि ये आयंस, इनकी मोबिलिटी ज्यादा होती है. ये छोटे छोटे बहुत पॉजिटिव आयन है. पॉजिटिव आयन मतलब इलेक्ट्रॉन चले गए मतलब बहुत छोटे छोटे आयन है. पीरियोडिक टेबल से याद है, पॉजिटिव आयंस आर मच स्मॉलर देन नेगेटिव आयंस. अगर सेम पीरियड की बात हो रही है तो ये याद आ रहा है? यू रिमेंबर दिस? यस, थैंक यू. डाइजेशन. थैंक यू माय गुड फ्रेंड्स. मयूख, मेधा, शालिनी, ब्यूटिफुल. या स्नेहा जी, हैट्स ऑफ टू स्नेहा जी. आई एग्री, शी इज डन अ ग्रेट जॉब. आपने पकड़ लिया. वो अभी डाइजेशन पढ़ा थी, मैंने भी डाइजेशन का ही सवाल पूछा. Yes, Rohit ji, absolutely. This is in digestion. So activators are metal ions and coenzymes were non-protein organic molecules. ठीक है, ये दोनों points इसमें अलग है. Now, this is very interesting. यहाँ पे भी हमारे पास inhibitors of poison. You be like, अरे यार, enzymes तो अच्छी चीज है, but क्यों? Why would we want to use inhibitors and poisons? कि कभी-कभी ना enzymes बहुत ज़्यादा secrete हो जाते हैं, and that's not good for us. So these guys, they reduce or completely destroy the activity of this. कभी-कभी ये करना पड़ता है. Like, I think the best example of this is antihistamines, right? Read up on it later on. किसी को बहुत छींक आ रही है, बहुत एलर्जी हो रही है, तो you immediately take an antihistamine. That helps. I'm not saying that that's an enzyme inhibitor, but something that helps slow down what is happening in your body, right? Something really is speedy and you slow it down. This is, any kind of a drug helps there. Hey. No, dude, Rohit, come on, man. Don't disrupt the class. Let's talk about surface chemistry. Ask me questions about surface chemistry. Don't spam here, man. It doesn't make the experience good for everybody, right? Be a good sport. Which one of the following statements is incorrect about enzyme catalysis? You've got 4 options here. Enzymes are mostly proteinous in nature. Enzyme action is specific. Enzymes are denaturated by ultraviolet rays at high temperature. Okay. Wow. Enzymes are least reactive at optimum temperature. Remember, हमको निकालना है कौन सा statement incorrect है. Which statement is incorrect? It's okay, Rohit ji. Don't have to apologize. We are all having fun. हम लोग साथ में सीख रहे हैं. We'll all give our best shot at NEET and also be our best version of ourselves. Yeah, that's equally important to me. Exam तो आएगा जाएगा, but I want you to be the best version of you, right? इसलिए मैं आपको थोड़ा बहुत टोकता रहता हूँ. I hope you don't mind. Yeah. Hey, what's up, Ayush? Hey. So यहाँ पे आंसर शेख जी एंड दीपान्विता जी बोल रहे हैं डी. ओके, या दिस तो काफी स्ट्रेट फॉरवर्ड चीज है ना. ऑब्वियसली दे वोंट बी लीस्ट रिएक्टिव, दे आर मोस्ट रिएक्टिव. बट देखिए ऐसे सवाल, व्हाई आई एम टेलिंग यू दिस इज कि this is question like this give you a very good revision. The reason why I ask students to do some sort of PYQs is देखो इस क्वेश्चन से और भी 2-3 आइडियाज मिल रहे हैं. अगर ये इनकरेक्ट है मतलब बाकी 3 आर करेक्ट. Which ones are correct? Enzymes are denatured by ultraviolet rays and high temperature. Good point to note. Ultraviolet rays मतलब बहुत high energy. High energy मतलब enzymes को break down कर देते हैं. And high temperature, enzyme action is specific, ये तो आप जानते ही हैं. और they are mostly proteinous in nature. That was the first thing आपको पढ़ाया. तो देखिए एक PYQ से 4 चीजें समझ में आ गई, right? So that's why I keep suggesting students कि करते रहो, सवाल करते रहो, especially in theory topics like this. Yes, it's D, Ayush. Yes. I asked what's incorrect, dude. Hey man, Rohit, that will not be tolerated here. Yeah, that's not cool, bro. Let's not do that here. Yeah, I'm serious. Let's keep the decorum of class. Would you do that in a real class? Be mature, man. Be mature. Yeah. Some industrial catalytic reactions. All of this is from NCERT, right? But इसमें से a couple of reactions जो आप 10 बार पढ़ रहे हैं. So that's why I say NCERT is a beautiful textbook, right? हेबर्स प्रोसेस कहाँ नहीं पढ़ा है. केमिकल इक्विलिब्रियम में पढ़ाया है, फिर आपको नाइट्रोजन के विच इज पी ब्लॉक में पढ़ाया है, और आपको यहाँ वापस सरफेस केमिस्ट्री पढ़ा रहे हैं. क्यों? क्योंकि यार अमोनिया बनाना इज अ बिग डील. उससे फर्टिलाइजर्स बनते हैं, TNT बनता है, लॉट ऑफ थिंग्स बनती है. नाउ हियर रिमेंबर द कैटलिस्ट वाज व्हाट? आयरन. अ प्रमोटर इज मोलिब्डेनम. तो पूरा हमने जो सब पढ़ा था हम लोग याद रखते थे कि कुछ 200-300 क्या कंडीशंस क्या थी मुझे याद नहीं आ रहा अभी. समथिंग लाइक दिस, राइट? कुछ हाई प्रेशर एंड कुछ टेम्परेचर का किसी को कंडीशन याद है? टेम्परेचर याद है किसी को? टेम्परेचर, या इट्स ओके, वी डोंट केयर अबाउट पीपल. लोग तो दुनिया में बहुत लोग बोलते हैं, आर फोकस इज स्टडीइंग, राइट? शेख जी, आई एम विथ यू. Please be active. You're great. Yeah. 200 to 300 atmosphere, 723 Kelvin. अच्छा रे यार, तुम लोग तो यार, hats off to you. Thank you. Thank you, thank you, thank you. 673 Kelvin, ठीक है. 673 to 723. I'll take that. मुझे honestly याद नहीं है. I'm not messing with you. Yeah. मैं पढ़ के पढ़ाता हूँ mostly, especially inorganic वाली चीज़ तो बहुत मुश्किल है याद करना मेरे लिए भी. I'm writing 723 because Shalini gave me the idea. But yeah, you guys saying 673, so let's keep it at that. Cool. Okay, great, great, great. So this was an important thing. The other thing was the contact process. Again, ये आप पढ़ते हैं in P block compounds and you're reading it here again. This is, and oh by the way, कहाँ था? हाँ वहीं पे था. Sorry, yeah, preparation of H2SO4, right? So vanadium pentoxide is a catalyst. And आपको बताया था, you can also have NO as a catalyst, but that would be a homogeneous catalysis, right? And you also had PT, just platinum as a catalyst. And all of these things are good catalysts, but industrial process में you use vanadium pentoxide. Why? Because it's expensive, and in industry your time is your main thing. Yeah, cost थोड़ा ज़्यादा तो चलता है. ये मैं आपको बार-बार छोटी-छोटी चीजें बताता रहता हूँ. Not necessary for NEET, but good to know. Yeah. Okay. Great. Now we have looked at, मैंने बोला था ना कि हम लोग दो चीजें खत्म कर देंगे जो जल्दी खत्म हो जाएंगी. Now it has been 27 minutes, right? And we're going to go on to colloids. ये काफी theoretical है, more of a story. Things that you will remember by making good flashcards. But the good thing is, most of this you already know from 9th grade. It's okay. 9th grade में 2 साल हो गए, but I'm sure ये सब चीज़ आप भूले नहीं होंगे. मुझे काफ़ी इंटरेस्टिंग चीज़ें लगती है, काफ़ी प्रैक्टिकल एप्लीकेबल है. सॉल्ट एक सोल्यूशन है, सस्पेंशन बनता है सैंड और वाटर का, यू नो दिस. एंड मिल्क क्या है? What is milk? Milk is an emulsion. Some of you are going to say who already know the answer. But for now, I'm going to call milk a colloid. A colloid. यानी कि गोल्डीलॉक्स वाला रीजन, नॉट टू बिग नॉट टू स्मॉल, परफेक्टली साइज बेड, राइट? सो अगर पार्टिकल्स ऑफ अ सोल्यूट बहुत बड़े हो जाते हैं, देन दे सेटल डाउन, एंड दैट इज व्हाट हैपेंस इन अ सस्पेंशन. अगर पार्टिकल्स ऑफ अ सोल्यूट आर रियली रियली स्मॉल, then that becomes a solution. But somewhere in between, they remain suspended, kind of the sweet spot, the Goldilocks spot जो मैं बोला था. That is what a colloid is. So that's the main way of knowing what a colloid is, the size of the solute particle. Okay, but we will call them right now colloidal dispersion or simply colloids. Let's walk through the motion. मैंने आपको बता दिया main idea क्या है कि size of the particles, that size being stabilized at that size. कुछ बड़ा हो सकता है, छोटा हो सकता है, but no, if I keep it at perfect size, it will give me some very beautiful results. So हर colloid में दो phases होते हैं, right? Yes. लक्ष्य जी, I'll try as well. मैं तो दोनों में बात कर रहा हूँ, मैं हिंदी इंग्लिश दोनों में बात कर रहा हूँ. Hold on, let me just scroll up because I may have missed a few messages because of my good friend spam over here. जो मुझे यहाँ पे अपने स्क्रीन पे 4-5 ही 4-5 लाइन्स दिखती है, तो I'm just going up to see. Okay, if I missed anything. Okay, no, right, no one else has said anything. Great. Lakshya, yeah. अगर बोलिए आप, so if you want to repeat anything, Lakshya, I will do that for you. Yeah, I will. Let me just put it at that. मैं ऐसी भाषा यूज करूंगा जो बहुत स्ट्रेट फॉरवर्ड है और मैं थोड़ा धीरे बोलने की कोशिश करूंगा. टेल मी इफ यू वांट टू रिपीट एनीथिंग. कूल. ओके, सो colloids have two parts or two phases. Now a phase is different from a state. A state is what you know from earlier grades, solid, liquid, gas. Phase is much more beautiful. A phase can just have a boundary that separates things. What is a phase? हम लोग बाद में बात करेंगे. एक्चुअली इट्स पॉसिबल कि एनसीईआरटी में ये डिफरेंस नहीं है, तो आप लोग को खुद एक्स्ट्रा थोड़ा पढ़ना पड़ेगा या गो आउट टू द जेई चैनल टू अंडरस्टैंड व्हाट अ फेज इज. बट मैं इसको जो है कॉग्निजेंट तरीके से बोल रहा हूं कि दो अलग फेज होते हैं, नॉट दो अलग स्टेट. ठीक है, क्या फेज? एक डिस्पर्जन फेज, एक डिस्पर्स फेज होता है, दूसरा डिस्पर्जन मीडियम. नाउ दिस इज एनालॉगस टू अ सोल्यूट एंड दिस इज एनालॉगस टू अ सॉल्वेंट, यानी कि स्मॉलर क्वांटिटी एंड लार्जर क्वांटिटी. ठीक है, ये दोनों चीजें हैं. ब्रॉड आइडिया ये. ओके, एनी डाउट्स? आई एम प्रीटी श्योर दिस इज राइट. डायरेक्ट ये जो है इसी चीज से हमको कोलॉइड बनता है. दिस डिस्पर्स्ड फेज इज व्हाट फॉर्म्स द कोलॉइड एंड द मीडियम इज बेसिकली कुड बी अ लिक्विड, कुड बी अ सॉलिड, इट कुड आल्सो बी अ गैस, कुछ भी हो सकता है. ओह इंटरेस्टिंग. तो फेज दो होते हैं बट ये स्टेट कुछ भी हो सकते हैं. हाँ, स्टेट कुछ भी हो सकते हैं. कीप दैट इन माइंड. तो लेट्स टेक द एग्जांपल ऑफ वन सच थिंग. या एक एग्जांपल है बहुत इंटरेस्टिंग चीज का, कॉल्ड गोल्ड सॉल. यहां पे डिस्पर्स्ड फेज होता है गोल्ड, अनसरप्राइजिंगली, और डिस्पर्जन मीडियम होता है वाटर. दिस इज एन इंटरेस्टिंग थिंग टू नो. बट व्हेनेवर यू हैव अ मेटल इन वाटर, it's very hard to keep that thing stable, because why would a metal get dissolved in water? That doesn't happen. A salt dissolves in water because pani hota hai polar, and also blue. I know there's a song going on in my head, blue hai pani, but whatever. Water is polar and salts are polar as well, so dissolve हो जाते हैं. But metal काहे dissolve होगा, right? So it's a fine art to be able to get metal to dissolve in water. Okay, that's quite insane. Anyway, gold sol is an example of such a thing. This is a heterogeneous system. Heterogeneous, you remember that when I was talking about एक solution, सही लिख रहा था मैं, solution, और हम लोग बात कर रहे थे suspension, and this is right in the middle, right? So suspension is heterogeneous, this is homogeneous. यानी कि ये बिल्कुल बीच में आता है इन दोनों के, but it is still said to be a heterogeneous system. क्योंकि heterogeneous मतलब कि अगर मैं यहाँ जाऊँ, यहाँ जाऊँ, यहाँ जाऊँ, यहाँ जाऊँ, exactly same concentration नहीं है, इसीलिए heterogeneous होता है. Heterogeneous का बहुत डायरेक्ट चीज है. If I go आंख बंद करके कहीं पे भी हाथ डालूं, तो exactly same concentration होगा. But that won't happen, right? Because my हाथ is going to be at a microscopic level. मेरा हाथ नहीं होगा, like law का हाथ होगा. I'm kidding. It'll be like a very like a microscope thing. Exactly. I read that, Mayuk. Neither dissolve nor settle down. Okay, great. And these particles are when they get dissolved in the solvent equivalent. I'm saying solvent equivalent ताकि आपको आसानी हो समझने के लिए, right? This has nothing to do with the solvent. It's just called a dispersion medium. Okay, great. तो इन दोनों में फर्क क्या होता है solution और colloid में? Main चीज ये है कि I can have very small particles in a solution. In a colloid, I can have larger particles. I can have one big molecule like a protein, aggregate of many atoms like say sulfur or gold and all of that, or some ions as well, like what you have in a detergent or a soap. Towards the end of the session, we look at these three different definitions of a colloid, different types, right? For a solution, it could be very small ions, very small, unaggregated, very far apart solutions. Electrochemistry में आपने पढ़ा होगा, हम लोग assume करते हैं कि अरे ये particles तो इतने far apart हैं, या electrochemistry equilibrium सब जगह, that they behave like a gas. तभी तो हम लोग उसके concentration terms को ऐसे लिख सकते हैं, right? अगर concentration ज़्यादा होती, then वो expression काम नहीं करेगा, या? अगर ये चीज़ अभी याद नहीं आ रही तो it's okay. But ये basis था of definition of how you could write concentration terms in brackets like this. Yeah? Okay. Anyway. Yes, my good friend Mayuk. Absolutely. Most medication you take is in the colloidal form. ठीक है? कुछ जगह लिखा होता है ना कि shake before use. तो that is usually अगर वो suspension होता है या फिर colloid होता है तो that's why उसको बोलते हैं shake before use. Those are very special types of colloids. We'll look at that. Mayuk giving me good material to talk about. I'll talk about that. So they are larger than simple molecules but small enough to remain suspended. Goldilocks वाला area, right? So here ये जो हमारे पास क्या बोलते हैं उसको thumbnail था, इस वीडियो का thumbnail में if you remember यही images हैं. अगर 1 नैनोमीटर से छोटा साइज है पार्टिकल का then you say that is solution. अगर it's between 1 and 1000 then this is a colloid which is what we are focusing on. अगर इससे बड़ा हो गया तो ये settle down कर जाएगा which is a suspension. लक्ष्य, are you okay? आप बोल रहे थे हिंदी में बोलने के लिए. Is this okay? Are you doing all right? Anything you want me to repeat? Please tell me. तो because of this really small size, उसका surface area काफी बढ़ जाता है. And I've been saying this a lot over the last couple of sessions. Size छोटा हुआ यानी कि surface area बढ़ गया. इसकी वजह से उसके बहुत interesting reactions होते हैं. In fact, most nanoparticles, their reactions happen because of this huge surface area to size ratio. Anyway. Surface area to mass, size, mass, दोनों चीजें. Surface area to mass ratio की वजह से ही सारे reactions होते हैं. Reactions and some very interesting properties. We'll look at some of those properties right away. पहले एक छोटा सा सवाल करते हैं. Out of these, which is a colloid? I've given you a hint already. Around 10 minutes back. No, around 8-9 minutes back. What is the answer to this one? The colloid out of these is urea, blood, cane, sugar, या NaCl. What do you think? Good to know, Lakshya. Blood is thicker than water. Yes, blood is the right answer. That was a line of a video game character that I like, called Bloodseeker. Anyway, yes, blood is the right answer. Absolutely. Simple सवाल और ऐसे सवाल आते हैं इस चैप्टर से. You see, I'm reiterating here. जब आप मेरे साथ पढ़ रहे हैं, you be like, ये क्या हलवा सवाल था भाई? The main thing is to be able to feel the same way when the actual test happens. ठीक है? I'm glad that all of you are getting this right. Also to my friends who are watching this not live afterwards. एक और सवाल. The size of a colloidal particle, just to make sure everyone is awake, the size of a colloidal particle is which of these four options? अभी आपको दिखाया था आप लोगों को. Note that all of these values are in meter. अगर आपको ये चीज सेंटीमीटर भी कर दें, that's also okay. But right now these are in meter. Okay? Mayuk is saying C. Shalini is also saying C. Lakshya is also saying C. C, 6 बार C Lakshya की तरफ से. Going once, going twice, and going 6 times. Okay, great. Medha is also saying C. I think everyone's saying C. Okay, great. This is the right answer. This is 1 nanometer, and this is 1000 nanometer. है ना? 10 power 6 यानी कि 1000 nanometer, which is also 1 micrometer. है ना? Same ही चीज है. Okay, great. Just be comfortable with changing these values up. थोड़ा बहुत इधर उधर मजा आएगा. ठीक है? Right. एक और सवाल. A colloid always contains 2 phases, is a true solution, contains 3 phases, contains only water soluble particles. ये तो अजीब सा सवाल है. Do you know the answer to this one, my dear friends? Oh God, there I go using my dear friends. I don't want to say my dear friends. You're all great. But it's like a phrase, when a teacher starts teaching, they have this one phrase that they say. I don't want to be that teacher. But Medha and Shalini and Deepanvita and Mayuk, 1, 2, 3, 4. And Lakshya, 5. I have 5 people saying option A. Great. Yeah, absolutely. Seedha sa sawal, right? This is the definition of a colloid. That's it. Okay. Last sawal, then we go on with some more theory. The volume of colloidal particle we see as compared to volume of a solute particle in a true solution VS could be which of these? Hey Ayush, yeah, some of them are neat PYQs, some of them have been made in-house. It's a mixture. I think it's 70 to 80%. It's 70 to 80% neat PYQs, and some of them have been, like this one is not a neat PYQ, this is something that we put in ourselves. The last couple were, yeah. Option A. I'm not sure if you guys saying option A to this one or the last one. रुको, देखने दो. Last वाले को आप लोग ये बोल रहे थे. इस वाले कोई आंसर नहीं दे रहा है. क्या हुआ दोस्तों? VC by VS क्या होता है? That's what's being asked for. VC यानी कि volume of solute particle in a colloid divided by volume of solute particle in a true solution. Oh, मैंने जब रिपीट किया सब लोग C बोल रहे हैं. शालिनी जी says C, Mayuk says C, Lakshya says C, Ayush says okay. Cool. Ayush says D. He has changed his answer from, yeah, look at that. What do you guys think? I'm inclined to go with Ayush. What are your feelings? Don't change your answer just because the teacher said so, but I'm really inclined to go to him. Yeah? See, this guy is supposed to be 1000 nanometer. This guy is supposed to be 1 nanometer. तो दोनों कैंसिल करो तो 1000 मिलेगा ना. 1000 यानी कि 10 power 3. Right? Yeah, volume of colloid should be much more. Right? I'm guessing can't get through this question. That's okay, Mayuk. पूछा जा रहा है कि volume of particle कितना होगा. वो तो मैंने बताया था ना कि size, ये जो है, जो हम लोग size बोल रहे हैं, is this say diameter is about 1000 nanometer. Volume क्या होगा? ज़्यादा बढ़ जाएगा. But here's the thing, right? It should be approximately this size. Like it cannot be smaller. It has to be larger. Just guessing off these options. It cannot be 10 power 23. That's ridiculous. It's not 1 because दोनों होते same होता. So the only guess should be between C and D, right? So D seems the most likely because दिया था यार volume of this is 1000 nanometer and this is 1 nanometer. Okay? Okay? I understand why this could be यार अरे 1001 में तो it could be 1000 power 3, right? So 10 power 9 होना चाहिए. Yeah, those are the extreme cases. But remember that this guy could be anywhere between this and that. Yeah, it has a range. So this has a range of this to 1 nanometer. So in दोनों के बीच में है. This is your colloid. I think this is going to be on top of my head. Yeah, as I thought. रुको. Let me write that one more time. I'll scratch everything else out so that everything is clear. देखो, colloid particle diameter ranges between 1 nanometer to 1000 nanometer. Cool. And what about a solution? A solution में the solute particle is smaller than 1 nanometer. यानी कि obviously colloid का volume is going to be greater than the volume of the solute. I'm talking about solute particle in both of these cases. ठीक है? Out of these options, this is the only one that makes sense. Mark it. ठीक है? मैं थोड़ा डिटेल में समझाया. Just going to see. Mayuk, are you all right? Lakshya, everybody else? That was the logic. And the reason why it's 1000 and not 10 power 9 or some other weird number is because देखो range हो सकता है. It could be this also, no? Or it could be this. It's got a range. Cool? थोड़ा मुश्किल बन गया सवाल. Apologies. But good to know, Medha. But yeah, this is okay, so what kind of classifications do we want to do with colloids? Remember, I told you कि phase और state दो अलग अलग चीजें हैं और colloids में दो phases होते हैं but states of matter तो तीन होते हैं. तो यानी कि तीन states of matter को मैं permutation और combination में मतलब gas gas solid 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 liquid कुछ भी करके कर सकता हूँ. तो होने चाहिए कितने 9 different types, but they aren't 9, there are 8 different types of colloids. ठीक है? We'll look at them in detail in a bit. I'm giving you a small hint. Yes, Mayuk, absolutely. Let's classify colloids based on these different things. Yeah, physical state of these guys, that was the first thing I was talking about. 9, no, this is 8, we'll talk about why. And then we'll talk about interaction between the dispersed phase and the dispersion medium. After that, particles of different kinds of particles, this and charge on particles. आज के सेशन में we'll cover until this. ये वाला पार्ट हम लोग नेक्स्ट टाइम करेंगे और ये इनफैक्ट सबसे जरूरी पार्ट है. बट टू अंडरस्टैंड दिस वी मस्ट गो थ्रू दीज थ्री फर्स्ट. ठीक है? ओके, कूल. सो व्हाट अबाउट फिजिकल स्टेट ऑफ डिस्पर्स्ड फेज एंड डिस्पर्जन मीडियम? ओके, सॉलिड, लिक्विड और गैस तीनों टाइप कर सकते हैं. एंड देयर आर ओनली 8. वेयर डिड द 9th टाइप गो? एनीबॉडी वांट्स टू गेस? 9 क्यों नहीं है? बिकॉज यू हैव 3 स्टेट्स ऑफ मैटर. दिस शुड बी 3 into 3 9, बट यहां सिर्फ 8 है. गेस करो. Until then, sit back and look at the amazing visuals behind me, in front of you. I feel rich just by looking at this. See this? Okay, the dispersed phase is solid, dispersion medium also is solid. So you know these gemstones, they get this beautiful color because of imperfections. Okay, you've got maybe some aluminum oxide. उसका कुछ कलर होता है. उसमें एक impurity डाल दो, like manganese or cobalt or something else. Cobalt से शायद blue color आता है. Chromium से शायद हरा कलर आता है. I don't remember this. I'm not. Yeah, I guess when I do DNF block, I'll go over this again. But कोई particular color कोई particular ion डालने से कलर बिल्कुल बदल जाता है. तो this is example of a solid in solid sol. These gemstones. Okay. Here's another one. Solid in liquid. मतलब हमारे पास जो कम है वो solid है and the bigger thing is liquid. Yeah, in a bigger phase, in a larger quantity. This is paint. इसीलिए paint has a shelf life. If you keep paint out for a long time, it gets messed up. Yeah, it dries up and all of that. क्योंकि वो colloids they lose their amazing powers क्योंकि वो जो अलग अलग particles से they come together, they coalesce, they aggregate. Okay. Mayuk is giving me an answer that I asked. Okay, good stuff. No interface, Medha. Lovely answer, Medha. No interface in gases. I really like that. Medha. That was such a pinpointed answer. Yeah, we'll talk about an interface. Why I'm saying this is such a cool thing for Medha to say. I'll talk about that when I get to this. So solid और liquid के बीच में एक बहुत clear boundary होती है. इसी को मैं phase boundary बोल रहा था. Interface, exactly. This interface is what I was calling a phase boundary. Yeah, दो phase तभी होते हैं अगर boundary होता है. अगर boundary है ही नहीं, तो फिर colloid कहाँ से होगा? That's exactly why I said कि Medha, the interface word was a very nice word for her to use. Cool. When the dispersed phase is a solid and the dispersion medium is a gas, this kind of a system is called an aerosol. And the example is smoke. Smoke आपको irritate क्यों करता है? Because there are solid particles that go into your lungs and dust and all of that as well. ठीक है? Dispersion medium था gas. मतलब बहुत सारी gas, थोड़ा सा solid. Another one is liquid dispersion phase. Dispersed phase, ED, in dispersion medium, solid. Jeez! Fat is your liquid, okay? Fat or, all of that, that's your dispersed phase. This is called a gel, okay? Other examples are butter and jellies. This seemed like a very, very chill thing because you have so many nice images, but this is just to help you remember these things nicely, okay? If you have the dispersed phase to be a liquid, dispersed medium to be liquid, hey, milk, this is called an emulsion. इसमें दो liquid कहाँ से? What are the two liquids यार in milk? Anyone wants to tell me what are the two liquids here? Just to make sure everyone कोई सो नहीं रहा है. इसमें दो कौन से liquids हैं दोस्तों? व्हाट आर द टू लिक्विड्स इन मिल्क? मिल्क लिक्विड तो होता है, ठीक है, बट दो लिक्विड कहां से आए? आई एम गेसिंग पानी होगा, बिकॉज अगर दूध में पानी मिलाया जाए तो दूध डज नॉट गेट अफेक्टेड, राइट? सो मे बी वन ऑफ द लिक्विड्स इज वाटर. What is the other liquid? Water and fat, Mayuk, yes. But यार, fat यानी कि oil does not mix with water. तो ये साथ में कैसे रह रहे हैं ये दोनों? I agree with you guys. Water is one of them. The second liquid is fat, is what Mayuk says, and I want to agree with Mayuk. I think what he's saying is absolutely right. Good job on that. But water और oil तो mix नहीं करते हैं. They are immiscible. So how is it that milk works out to be an emulsion? ये कैसे काम करता है? आप सोच के बताइए थोड़ा सा. You try it out. Yeah, that's why in 9th grade वो था कि आप oil और water को mix करोगे तो mix नहीं होते. They're immiscible liquids. They form a layer. Hence आप separating funnel से उनको separate कर सकते हो. याद आया 9th standard से separation of substances में से, है ना? But यहाँ पे दोनों महाशय अच्छी तरीके से mix कर रहे हैं. How is that? Any idea? There is something. Let's take what Medha said. There is an interface that is formed and that is stabilized. That interface is stabilized because of something known as emulsifying agents. Agents of chaos. No, they actually keep the peace. Yeah, like United Nations. Exactly. Fats exist as small globules. But what keeps the globules small? Emulsifying agents. Keep that in your mind. सोच दिमाग में रखिए. यहाँ पे एक और एग्जाम्पल है, लिक्विड इन गैस. इसको भी एरोसॉल ही बोलते हैं, जस्ट लाइक सॉलिड इन गैस, राइट? तो अगर मेरा डिस्पर्स्ड मीडियम गैस है तो हम उसको एरोसॉल बोलते हैं, ठीक है? ये भी मैं आपको एक क्विक टेबल दूंगा, यू कैन टेक अ स्क्रीनशॉट ऑफ दैट. और अगर गैस जा रहा है सॉलिड में, यानी कि ये प्यूमिस स्टोन, उसकी डेंसिटी बहुत कम होती है, सो मच सो कि यू नो इट फ्लोट्स ऑन वाटर. या रबर, फोम, ऑल ऑफ दीज थिंग्स आर सॉलिड सॉल्ट्स. Example of gas and liquid, this is a very interesting one. Froth, yeah, soap, lather. Let me write that down. Another example is froth. Froth, flotation, हम लोग पढ़ेंगे अगले सेशन में, not अगले सेशन, अगले चैप्टर, मंडे को, मंडे, ट्यूसडे, I think we'll do that. ठीक है. Sponge is a solid solid. Mayuk, the thing is, sponge is a solid salt. That's an interesting thing to think of. Sponge, most sponges these days are plastics, right? And they're made with this structure. उसके अंदर air trapped होती है. हाँ, I think theoretically बोल तो सकते हैं, बोलने में क्या जाता है? Air is trapped inside, yeah. But the small thing is कि अगर मैं sponge को पानी में डालूं, तो वो पानी absorb कर लेगा. I don't know if that makes any difference. I have to look it up too. I'm just thinking out loud with you. Pumice stone के मैं पानी में डालूं, तो वो air जो trapped है वो निकलती नहीं है. वो air वहीं पे रहती है. That's what I'm trying to say. अगर मैं sponge को पानी में डालूं, तो हवा निकल जाती है. तो it's not a very stable colloid if it was even one. I don't know if I can call it a colloid. I don't think I can call it a colloid. It just has a structure जिसमें हवा होती है. But pumice it floats on water. Yeah, इसलिए थोड़ा सा लगे. But a good question, Mayu. That's a very interesting question. ठीक है. तो ये मैंने 8 चीज आपको बताई, और जैसे आपको दोस्त पहले बोल रहे थे कि gas in gas is not a sol because there is no interface. I'm going to use what Medha said, and no interface, or there is no, phase boundary. I'm going to use both of these terms. ठीक है? Since ये दोनों चीजें नहीं है, इसीलिए gas और gas sol नहीं होता है. Important चीज. ठीक है? Movies got fun. If it's related to chemistry, please ask away. Especially if it's related to surface chemistry, please ask. Okay, great. गैस मिक्सचर क्यों नहीं, आपको अभी मैंने बताया. Won't bore you with the details. Blah 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 blah. But by the way, it says homogeneous system here. ये मैंने gaseous state में बताया था क्यों homogeneous है, not heterogeneous. There can be an argument about this. Movies got fun. If it's related to surface chemistry, please ask. Homogeneous in the sense कि अगर मैं दो gases को इस container में डालूं, this is my favorite prop, yeah, then they get mixed up very nicely. But the air inside this container, or the air here, because I'm breathing it, is very different from the air in that corner of the room. So in that way, air here and air there could be heterogeneous, right? Because वहाँ पे मैं डालूँ, यहाँ पे हाथ डालूँ, concentration अलग होगा. But air in general is homogeneous if you close system and all of that. ठीक है? थोड़ी सी बारीकी वाली बात है. Maybe in a viva somebody could ask you these questions. ठीक है? हाँ, तो याद रखने वाली टेबल आपके यहाँ पे है. Please take a screenshot. डिस्पर्जन मीडियम अगर पानी है तो उसको हाइड्रोसॉल या फिर एक्वासॉल बोलते हैं. एयर है तो एरोसॉल बोलते हैं. ये दोनों चीजें आर मोस्ट रेलेवेंट टू अस. But there are a couple of interesting other things also that I mentioned. Alcohol में alcohol बोलते हैं, benzene में benzosol बोलते हैं. Yes, benzene is a great solvent, and this is an organic solvent. Okay. Also, it is non-polar. Organic chemistry में ये सब चीजें बहुत मायने रखती हैं. ठीक है? Alcohol is a polar solvent, also organic. ठीक है? Cool. All right. Any doubts so far? काफी भारी सेशन रहा है. All of you have been very active, which is very nice. But काफी भारी हो गया ना, काफी ज्यादा थियरी. कोई डाउट्स है? Anything so far? I didn't even stop to ask you यार. 50 मिनट हो गया. Sorry. मुझे बहुत मजा आ रहा पढ़ा है. मैं पूछा ही नहीं आप लोगों से. क्या चल रहा है? Any doubts guys? All good? एक सवाल हो जाए. Yeah. Fog is a colloidal solution of which of these? No doubts, Mayu? Great. Anybody else? कोई भी doubts है पूछ लो यार. Surface chemistry related, I'm here for you. General chemistry वाले doubts हैं, I'll try and answer them, but if it's too much, then maybe I'll say कि hey ये वाला session देखो, ये वाला video देखो. ठीक है? Okay. Liquid in gas, शालिनी, दीपान्विता, मयूख, लक्ष्य, मेधा, 5 लोग. Great. So और भी कोई बोला क्या? शालिनी started this off. Yes, yes. Okay, great. Everyone's saying liquid in gas. कौन सा लिक्विड, कौन सी गैस? कौन सा लिक्विड, कौन सी गैस? गैस तो एयर हो गई. व्हाट लिक्विड इज दिस? व्हाट लिक्विड? हवा में कौन सा लिक्विड होता है? मुझे तो नहीं दिख रहा कोई लिक्विड. व्हाट लिक्विड इज दिस? हे पूर्वी, थैंक यू फॉर ज्वाइनिंग अस, और इफ यू बीन लर्किंग अराउंड, दैट्स ग्रेट. थैंक फॉर दिस आंसर. You're all absolutely right. What liquid? Water droplets. Absolutely right, Mr. Mayuk Sen Gupta and Dipanvita hitting the nail on the head. The head. दी तब यूज होता है जब you have vowels like A, E, I, O, U के पहले दी होता है, otherwise it's the. Small things. What's up, Purvi? That's lovely. 8th grader. Good to have you here. Milk is a colloid in which? ये तो सवाल आपसे पूछ चुका हूं. बता दो यार जल्दी आंसर. विल गो टू द नेक्स्ट वन. बहुत डिटेल में इस सवाल का जवाब आपको बता चुका हूं. आई फॉरगॉट दिस क्वेश्चन वाज हियर. नहीं तो इतने डिटेल में नहीं पता था. Yeah, this one's option A. Yeah. Mayuk, Shalini, Lakshya. Good job everybody. Oh, Dipanvita started this off. Sorry, Dipanvita. It's D right there. Yes. Lakshya, Medha as well. Okay. Great. Gungun. Yes, absolutely. Hey, Gungun. I haven't seen you around before. Okay. Good job, everybody. Liquid, fat and water, etc. So, that was the basis, classification based on this. The interaction between dispersion phase and dispersed medium. This is very interesting. Lyophilic and lyophobic. Philic matlab great, phobic matlab not so great. Phobic matlab scared, phobia matlab डरावनी चीज. Philic matlab they like each other, which means they interact very nice with each other. Yeah? Okay? No, Purvi. Absolutely. That's very nice to know that you're checking out everything so early on. Amazing. We have really great teachers on a 6 to 8 channel. You should check that out on a regular. Yeah? Baiju 6 to 8. Thanks for sticking around. Thanks for dropping by. Purvi, sorry. Okay, so what is this philic and phobic वाला business? देखो, अगर there are interactions, you know, this polar, non-polar वाली चीज मैंने बोली थी, maybe that's one thing. So if there is both like dissolves like, right? So अगर there is some sort of interaction between dispersed phase and dispersion medium, then this is called a lyophilic or liquid loving colloid. Okay, अगर मेरा जो है dispersion medium liquid है तो this can be formed easily and is reversible. यानी कि एक बना and मैं उसको वापस solution बना सकता हूँ. Solution colloid, etc. I can do that. Or I can even form a suspension. I can do a lot of funky things with it. मैं उसको अलग भी completely कर सकता हूँ. यानी कि for your centrifugation machine अलग हो जाएंगे. मतलब literally I just have to spin it around really fast and I can separate out the colloid and this thing. And बस mix करो, mix हो जाएंगे. So they are known as reversible salts. Important thing to note. Please make a note of that. Okay. Cool. Hey, Purvi is all right, I think. Rohit, I think is moderating session. I think Purvi is okay. Don't worry. We don't have to delete her message. Purvi's message can stay. It's all right. Okay. Lyophilic colloids का example यहाँ पे दिए हुए हैं. Glue, gelatin, starch, egg, rubber, etc. दूसरा है lyophobic. यानी कि lyophobic का मैं आपको already example दे चुका हूँ. Milk, right? They are stabilized by a third party. Yeah. There is no affinity. मतलब कि दे आर इररिवर्सिबल. एक बार बन गया तो बन गया और एक बार डिस्ट्रॉय हो गया तो डिस्ट्रॉय हो गया. यानी कि अगर मैंने इफ आई यूज सेंट्रीफ्यूगेशन टू सेपरेट देम आउट, देयर इज नो वे दे आर गोना कम बैक टुगेदर. या अनलेस देयर इज सम मिरेकल. एनीवे, लिक्विड हेटिंग, स्कैर्ड, फोबिया, फियर, राइट? इसके एग्जांपल आपको दे चुका हूं. they can't be formed easily. You gotta do special things like use emulsifying reagents and they readily precipitate out. Precipitate यहाँ कैसे आया? Precipitation reaction you may have studied. Precipitates मतलब कि जब aggregate हो जाता है, मतलब many colloids come together to make a big particle, यानी कि suspension जैसा particle, then life is not good. Then मतलब कि you go size greater than 1 nanometer, right? Not 1 nanometer, what I'm saying, greater than 1000 nanometer, तब things are not good. Not good. Yeah, that's what this is. So that's why they're unstable and irreversible. अगर एक बार colloid destroy हो गया यानी कि aggregate हो गया तो कहानी खत्म. Okay, cool. That's what I was trying to tell you. So they're irreversible. Let's move on to the next one. So अगर पानी है तो इसको हाइड्रोसॉल बोलते हैं और हाइड्रोफिलिक और हाइड्रोफोबिक होता है. लाइयो के बजाय I've just replaced that word with hydro. Okay. Bhaskar ji, good to know. I know यार, a lot of things have been deleted from NCERT, but until NTA tells us कि नीट नहीं पूछेगा, तब तो हम लोग पढ़ाएंगे, right? Otherwise, hey, this is very important for you from your doctor की journey point of view also. तो कुछ नहीं हुआ, at least nothing else, then this is good knowledge to gain. ये तो पूरा चैप्टर कहानी ही है, कहानी की तरफ पढ़ लीजिए, and फ्लैश कार्ड्स के साथ अगर नीट में पूछा गया तो सवाल भी हो जाएंगे. हाँ मयूख, I think so as well. अभी के लिए तो है, until NTA says otherwise. Quick question: which of these is a lyophobic colloidal solution? What do you think? इसमें से कौन सा lyophobic है? Aqueous starch solution मतलब पानी यानी कि water and aqueous protein solution gold solution या फिर polymer solvent in some organic solvents. Ooh, interesting. Mayuk says C. Mayuk saying C. Lakshya saying C, Gungun saying C, Vaishnavi, good to see you here, also saying C. Dipanvita also with C. Looks like C को lock करना ही पड़ेगा. Shalini also saying C. Good job everybody, great going. मैं आपको हिंट दे चुका था because अगर मैं ये आपको नहीं बताता तो आप लोगों को शायद पता नहीं चलता, right? कि यार गोल्ड सॉल ही है because it's a negatively charged sol. I gave you a lot of theory as to why it would be so. ये सब देखो these are polar, okay? Pani and starch and proteins, all of these are polar. This is non-polar, both of these chaps. Yeah, both the polymer and organic solvents. So like dissolves like. Yeah, so they all lyophilic. Only lyophobic one is this chap right here. Okay, great. Now, based on this gold sol wala example, I want to talk about the last part of this section. I'll just take maybe 2-3 more minutes. That's a very good question, Mayuk. The thing is कि theory can only take you so far, right? In fact, for the longest time ये मालूम ही नहीं था कि गोल्ड डिसॉल्व भी होता है पानी में. डिसॉल्व इन सेंस कुछ भी करता है पानी के साथ. टेक अगर आपके पास सोना है, पानी में डालिए, कुछ नहीं होगा उसको. लिटरली जस्ट प्लॉन्क टू द बॉटम ऑफ दैट पानी, राइट? सो एनीवे, साइंटिस्ट डिड दिस अमेजिंग डिफरेंट थिंग्स, राइट? दे मेड गोल्ड के बहुत छोटे छोटे पार्टिकल्स, डिपेंडिंग ऑन द साइज ऑफ द पार्टिकल अलग अलग कलर के सॉल्व बन रहे थे. गोल्ड पार्टिकल्स का बहुत फेमस एग्जांपल है. और कोई भी नैनो टेक्नोलॉजी का लेक्चर करना होता है ना, तो पहली चीज यही, गोल्ड सॉल्व के अलग अलग दिखाए जाते हैं, कलर्स दिखाए जाते हैं. इट्स अ ब्यूटीफुल एक्सपेरिमेंट. सो या you need some stabilizing agents for it to work, and at that size it kind of works. And the fact is that there's a negative charge form, इसकी वजह से वो stable होता है. वो charge के बारे में हम लोग अगली बार बोलेंगे. Hi Vaishnavi, hey. So I didn't see that message पहले. Hey Seema Purva, good job on the last answer. See, yeah, I hope that answers your question, Mayuk. Yeah, the concept is the bond शब्द ही एक risky शब्द है यहाँ use करना, ठीक है? इसलिए मैंने इतना डिटेल में थोड़ा ज्ञान दिया. If it felt like I didn't answer your question because हमें अभी तक चार्ज को की बात की नहीं है, चार्ज की हम लोग अगले सेशन में करेंगे. That's when I'll maybe be closer to answering your question as to what type of bond there is, or there's no bond as such. Okay, we'll talk about that later. So anyway, to types of particles of this DP क्या है? Dispersed phase, यानी कि smaller quantity. Okay, stuff that is there in a smaller quantity, उसकी हम लोग बात करें. Multimolecular मतलब कि मे बी S8 सल्फर के 8 मॉलिक्यूल्स आके एटम्स आके बन गए मैक्रोमोलिक्यूलर एसोसिएटेड. ये दो 2 out of 3 ऑलरेडी नो, ठीक है? दे एग्रीगेट टुगेदर एंड दे फॉर्म साइज ऑफ दिस रेंज. दिस इज व्हाट अ गोल्ड सॉल इज. एंड ऑल्सो Ag तो सिल्वर होता है, बट आई थिंक सिल्वर का भी बन सकता है. बट यू नो अबाउट गोल्ड सॉल. एंड ऑल्सो दूसरा कौन सा? सल्फर. या दीज आर पॉपुलर एग्जाम्पल्स ऑफ दीज चैप्स राइट हियर. ओह, दैट्स ऑन द नेक्स्ट स्लाइड. माय बैड. गोल्ड एंड सल्फर. वी गुड? Yeah, chat is quite silent. I'm just checking in everyone's alive and happy. Macromolecular colloids का भी एग्जाम्पल बता चुका हूँ. Proteins, right? If they have very large particles, any type of polymers that form, एक एक मॉलिक्यूल बन सकता है 1000 नैनोमीटर के आसपास, मतलब बहुत बड़ा, या बिटवीन 1 नैनोमीटर एंड 1000 नैनोमीटर, मतलब काफी बड़े बड़े पार्टिकल्स बन सकते हैं. पार्टिकल्स ही मॉलिक्यूल्स बन सकते हैं. इसको हम लोग मैक्रो मॉलिक्यूल, मतलब कि एक बड़ा मॉलिक्यूल. मल्टी मॉलिक्यूलर मतलब मेनी मॉलिक्यूल्स का मटेरियल. मैक्रो मतलब बड़ा मॉलिक्यूल. ओके, इंग्लिश, use English to your advantage. Okay, so these are quite stable, and here are the examples. Rubber, yeah, starch, cellulose, proteins, blah 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 blah, nylon, polystyrene, synthetic rubber. You'll see that a lot of these are polymers, and that's a small hint for you to take away from here. Protein, as you know, is an amino acid bonding itself, it's primary, secondary, tertiary, quaternary, etc., etc. Right? Last one here for today is associated colloids. Now, what is an associated colloid? मतलब कि देखो, मेरे पास कुछ charged particles हैं. This is a very nice example because it links to the next idea as well, which is the charge on colloids. So at a low concentration, some substances they behave as strong electrolyte, like Cl minus Na plus तो है ही, but think of a big thing and at the end they have this. मतलब they have a negative charge here. There's like a long chain. Let's call it a hydrocarbon chain. I'm giving you these things to read about ताकि आप लोग पढ़ के आए before the next session. And some charge. ठीक है, तो ये may behave as strong electrolytes, but at high concentration they form a beautiful structure, which what I'm calling an aggregate, and that associated form, that is a colloid. This is called a micelle, and ये हम लोग करेंगे अगले session में. Soap molecules, class 10. Good job. Okay, we'll talk about micelles, which are soaps and detergents, in the next session. It looks like we are just out of time, so I'm just going to give you the homework question and we'll call it a day. Here's the first homework question on your screen right now. Take screenshots or come back to the video later and answer it in the comments, please. It's really cool that you guys are actually giving me answers on the homework questions. Most of these are from previous year questions or some slightly थोड़े tricky वाले सवाल हैं, वो मैं यहाँ पे डाल रहा हूँ. That was one. This is the other one. So हमने काफी interesting चीज़ आज cover की. We have 2 more sessions to wrap this chapter up, which are going to happen on Thursday and Friday. Tomorrow I'm going to continue with states of matter. Quick summary of what we did today. काफी भारी भारी चीजें की, yeah. Some examples: invertase and lactobacilli to be the enzymes for these enzyme catalyzed reactions. The steps in any enzyme is first formation of this activated complex and this perfect lock-in key model. After that, you get these separated products. And the thing is that they're quite efficient. Look at that, 1 million molecules of the reactant per minute. They're specific, यानी कि invertase सिर्फ वो sugar invert करेगा और कुछ नहीं करेगा. And they're very specific to that particular biological reaction itself. Particular temperature, yeah, and at a particular pH. That temperature range क्या था, याद आ रहा है क्या? 298 Kelvin to 310 Kelvin. Yeah, that was what that was. pH range यहाँ पे दिया हुआ है. And a couple of industrially important reactions on your screen right now. Here are the catalysts used for this, because our whole focus was catalysis. Hey, KB, wow, no way, dude. Wow. Hats off. Good job. I hope you're liking Rishikesh and AIMS and पढ़ाई में मजा आ रहा है. Get in touch on Telegram, man. I teach came on Telegram. It will be great to chat. I'm in touch with some former students there. This is me on Telegram. Anyway, so yeah, that's all I have for you. Oh, hold on. Yeah, a couple of other things. Yeah, I got distracted by that chat. Okay, so colloid particles are in this sweet Goldilocks spot between 1 to 1000 nanometer. Suspension particles are larger and solution particles are smaller. There are, no ninth, this thing, there are 8 of them, different types of colloids, yeah, because there is no interface over here, as Medha pointed out rightly, and Mayuk also said, कि भाई इसमें तो कोई phase boundary ही नहीं है, तो इसलिए कुछ नहीं होगा. No phase boundary. मैं बार-बार इसको लिख रहा हूँ, तो students forget this, ठीक है? No phase boundary, no interface, इसलिए gas and gas नहीं है. Different types of salts, yeah, water अगर base है तो alcohol, benzene, air, base यानी कि dispersion medium. And we looked at lyophilic, lyophobic colloids. Detail में गए कि अच्छा अगर पानी हो तो hydrophilic, hydrophobic हो जाएगा. And lastly, we looked at 3 different types: multimolecular, macromolecular, and associated colloids. Medha said it. Yeah, Medha and then Mayuk. I said Mayuk by mistake right after that, I know. All right, cool. Thank you so much for sticking around. I have been shooting over like by 4-5 minutes every session. I hope that's okay. Yeah, I wanted to keep all these sessions at a logical end. So please read NCERT And I'll see you again on Thursday and Friday for this session as a continuation of surface chemistry. Tomorrow for states of matter. After this, next week, we're going to do thermodynamics, my favorite chapter, and metallurgy as well. Thank you so much, everybody. Great being with all of you. I'll see you around. Oh, yeah. And by the way, do share this with your friends if you like this. Yeah. Bye. Well done.